Well, happy Saturday. Today we are going to be talking about amplitude and period. We're going to do a lot of graphing today, and so I'm going to start with an example of what we're going to do is graph y equals 4 sine of theta. And I'm going to make a little table of values over here. Our independent variable I'm going to call x equals theta. I got to learn how to make some straight lines. And our dependent variable is y equals sine of theta times 4. Put a 4 in front of this. Okay, so I'm going to do some points that we're going to get used to here are going to be 0, 90, 180, 270, and then back to 360 degrees. Alright, we should know that the sine of 0 is 0 times 4 gives us 0. The sine of 90 is 1 times 4 gives us 4. The sine of 180 is 0 times 4 gives us 0. The sine of 270 is negative 1 times 4 gives us negative 4. And the sine of 360 is 0. And of course times 4 gives us 0. So we're going to come over here and we're going to graph this. And on the x-axis, although I'm actually going to call this the theta axis, I'm going to have 90, 180, 270, and then 360. And it looks like I need to have a range of up 4 and down 4. That would be negative 4, and that would be positive 4. So we just plot these dots. 0, 0. 94, 180, 0, 270, negative 4, and 360, 0, and we get our first graph of sine. This is y equals 4 sine of theta. And there we go. So I want to give you two statements about amplitude and period. Okay, amplitude is going to be how far from the middle of the graph, the symmetric middle of the graph horizontally, how far did we go up or down, that distance. So I'm going to look right here at the top of this wave, from here to here. What is this distance right here? That is called the amplitude, if you can figure that out. And of course, we went from 0 up to 4, so I'm going to say the amplitude is 4. Notice that we could even go from the middle down to a low point and look at that distance, and that distance is also 4. The period for sine or cosine is going to be how long it takes to do a loop on top and a loop on bottom for sine. And this is one full picture of sine, and this happens in a distance along the independent axis of 360 degrees. So there's our first graph. All right, let's do another one. Now I'm going to do a cosine graph. So let's do y equals 3 cosine of theta. I'm going to have the same kind of table over here. I'll have x equals theta, and I'll have y equals 3 times the cosine of theta. Well, you can see it over there. So if theta is 0, and theta is 90, and theta is 180, and theta is 270, and theta is 360, let's find 3 cosine of theta. The cosine of 0 is 1 times 3 is 3. Cosine of 90 is 0 times 3 is 0. Cosine of 180 is negative 1 times 3 is negative 3. And cosine of 270 is 0 times 3 is 0. Cosine of 360 is 1 times 3 is 3. So let's go look at this graph over here. A little bit further. This is our theta. We're going to have 90. Again, get used to these points. 90, 180, 270, and 360. Now our distance we go up and down is up to 3 and down to negative 3. So we just plot our points. Now here we start at 0, 3, and we're going to start at a peak. Then we have 90, 0, we have 180, negative 3, 270 0 and back to 363. And this is going to be one full picture of a cosine graph. Still loopy like a sine graph is, but we need to go from an amplitude of 3, or the top point or a crest of 3, back to when we get to that crest again. That's going to be one full period for cosine. And we notice that distance again was 360 degrees. And also from the symmetric horizontal center of our graph to a peak or down to a trough, either one of these, that defines our amplitude. And so for this graph, I'm going to have an amplitude of 3, and the period is equal to 360 degrees. So it looks like it's pretty simple. If we see a number in front of cosine or a number in front of sine, that becomes our amplitude. And so far our period for both examples has been 360 degrees. Okay, let's do another example here. What about y equals the sine of 3 theta? Now I'm going to make a chart here that you're probably not used to. I'm going to have 3 theta, and I'm going to have theta, and then I'm going to have the sine of 3 theta. Now underneath 3 theta, I'm going to have our normal points: 0, 90, 180, 270, and 360. Get used to those because we're going to use those a lot. Now if 3 theta is 0, then 1 theta is 0. If 3 theta is 90, 1 theta is 30. And if 3 theta is 180, 1 theta is 60. Notice I'm just dividing these by 3. So 270 divided by 3 is 90. 360 divided by 3 is 120. Now I'm going to look back over here, the y equals sine of 3 theta. I'm just going to be using these 3 theta values before I take the sine. So the sine of 0 is 0. The sine of 90 is 1. The sine of 180 is 0. The sine of 270 is -1. And the sine of 360 is back to 0. Now when I label my graph, however, I'm going to have my thetas are going to be labeled right here as 30, 60, 90, and 120. And then I need to go up and down 1 and -1. So I'll just plot these points. I'm plotting theta versus sine of 3 theta. So I have 0, 0. I have 30 degrees 1. I have 60 degrees 0, 90 degrees -1, 120 degrees back to 0, and then I've got that sine graph. I'm going to check on our time here because you know we can't go over 15 minutes for these here. Check on right here. Okay, so we're doing well. Alright, so let's take a look again at our amplitude. Our amplitude is that distance or that distance, which is 1. And our period is how long it takes to see this picture for sine. One upper hump and one lower hump. And this distance from there to there is 120 degrees. So our period is 120 degrees. Okay, so let's do another example. Let's do cosine of 2x, and I'm going to call it x instead of theta. And anytime you see that, we're going to be using radians instead. Okay, so I'm going to have x, and then I'm going to have just x equals theta. I'm just going to call it x, and then I'm going to have cosine of 2x. Now here, like I had up here, I still am going to put 0, 91, 82, 73, 60, except I'm going to be using radians this time. So in radians, 0 degrees is 0, but 90 degrees is pi over 2. 180 degrees is pi. 270 degrees is 3 pi over 2. And then 360 degrees is 2 pi. Okay. Let me get my pen back here. Alright, so if 2x is 0, then x is just 0. And if 2x is pi over 2, then x is pi over 4. If 2x is pi, then x is pi over 2. And then we have 3 pi over 4, and then we just have pi. Now let's take a look at the cosine of 2x. The cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And the cosine of 2 pi is back to 1. So let's just graph this. Okay, I'm going to be using these x values: 0, pi over 4, pi over 2, 3 pi over 4, and pi. And then I'm going up and down this time just 1. And I'll plot my points. 0, 1, pi over 4 is 0, pi over 2 negative 1, 3 pi over 4 is 0, and pi 1. And I just sketch the graph between the dots. There we go. That's not that great, but... And then let's take a look at our amplitude. Our amplitude is here, or here, or here. All of those amplitudes are 1. And the period is the distance it takes to see the whole graph, which here is pi. Okay, so this is what we're going to say to close this out. We are going to say that the period of y equals cosine of bx is 360 degrees divided by b, or if we're dealing with radians, 2 pi divided by b. Notice that here we were dealing with radians. If we take 2 pi divided by that number 2, which is the number in front of the x, we get our period of pi. And the amplitude of y equals, let's use sine this time, a sine of x is equal to a. So the number that is in front of the sine or cosine is your amplitude. And of course, if you don't see 1, then it's just a 1. And that is enough for now.